Okay, today's focus is really just about parallelograms. We are still in the quadrilateral unit, so we're talking about four-sided polygons. But today we're really going to focus on the green circle, which are just the parallelograms. And when we talk about parallelograms, that does include all rhombi, squares, and rectangles. Remember, not every parallelogram is a rectangle, not every parallelogram is a square, not every parallelogram is a rhombus. These have very specific, more detailed characteristics about them than just a general parallelogram. But all rhombi are parallelogram, all squares are parallelograms, all rectangles are parallelograms. In fact, all squares are rectangles, and all rectangles are parallelograms. But not all parallelograms have these specific characteristics. A parallelogram probably is defined by two sets of congruent sides, two sets of parallel sides, and then we can talk about the other properties that it has. Okay, again, we're still in quadrilaterals, but we're going to specifically just look at parallelograms, and usually we're looking at a general parallelogram that is not a rectangle, square, or rhombus, but again, a parallelogram can be all of those things as well. Okay, so let's go back to just parallelograms. So here's our general view of what a parallelogram is labeled as. These opposite angles are congruent. Those angles are congruent. We are looking at those opposite sides are congruent. Those opposite sides are congruent. And we also know that these sides are parallel and these sides are parallel. And if you think about old school stuff, if these two things are parallel and this can be viewed as a transversal, then these two angles have to be supplements to each other, right? They're actually alternate interior angles if you view that as a transversal. And so when you look at some of these characteristics, both pairs of opposite sides are parallel, both pairs of opposite sides are congruent, both pairs of opposite angles are congruent, and consecutive angles are supplements. That's what we just said here. That's kind of old school. And the diagonals bisect each other. So if I drew diagonals on here, the diagonals intersect at their midpoints. Again, it doesn't say the diagonals bisect the angles. It says the diagonals bisect each other, meaning the two diagonals bisect each other. Okay, pretty much these properties are the way you prove something as a parallelogram, but this particular sheet thinks there are 6. Again, this is the definition of a parallelogram. Both pairs of opposite sides are parallel. You can show me that both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. An interior angle is supplement to both consecutive. So if you show me that, both, not just one, but both. The diagonals bisect each other, or a pair of opposite sides is both parallel and congruent. So you can show me that those two are congruent and those two are parallel, and that would be enough to prove that that's a parallelogram. We are going to look at the area of a parallelogram. The area of a parallelogram is just base times height, very similar to a rectangle and a square and a rhombus because they're all parallelograms, and so they all have that same thing. The height is the distance between the two bases, the two congruent bases are these two. Now I could certainly lie it like this, and then this would be the height. That, again, the height, you're going to drop a perpendicular, right? Because the shortest distance between two parallel things is some perpendicular line. So we know that the height is always perpendicular to a base. And then the perimeter is the same as all perimeters. It's the distance around. So if you go around a parallelogram that has two pairs of congruent sides, you're just going to go one, the other, one, the other. And so you're going to get 2b plus 2c or 2l plus 2w or whatever you're going to look at. Okay? Today, we're going to focus on the properties of parallelograms and then doing problem solving about the area. And then tomorrow, we're going to do coordinate proofs where we're looking at proving different quadrilaterals are parallelograms. Okay? I just want to re-emphasize that if you get kind of confused on a parallelogram, if you just did your best to just draw a parallelogram, okay, if I just did that, again, this is a parallelogram if and only if, well, that is congruent to that. This is congruent to this, right? That'd be enough to prove it's a parallelogram. But we also know that this is parallel to this. How would you show that? Because what if it looks like that? Well, remember, can't we just show that their slopes are the same? So parallel means the slopes are the same. We'll say equal slopes. If we wanted to show something perpendicular, well, then we need to look at opposite reciprocal. And we'll look at perpendicular later. Like if you wanted to prove something was maybe a rectangle or a square, you'd want to prove this is a right angle. Proving this is a right angle is showing that these are opposite reciprocal slopes. But just showing that these are having the same slope, they're parallel, and then we could show that maybe these two have the same slope, so they're parallel. This angle, let's say, is 70. Well, then we automatically know that this is 110, that this is 70, and that this is 110, because we know opposite angles are congruent in a parallelogram. We know that consecutive angles are supplements to each other, and we could even draw the diagonals. And we know that this point is the midpoint of both of those diagonals. Now, are the diagonals the same length? No. Parallelograms don't necessarily have congruent diagonals, meaning diagonals are the same length. You know, when you looked at the characteristics, right, the diagonals bisect each other, consecutive angles are supplements, both pairs of opposite angles are congruent, both pairs of opposite sides are congruent, and both pairs are opposite sides are parallel. That's kind of what we drew here. Again, which means that this is congruent to that, and this is congruent to this. But the diagonals not necessarily the same, because really, we're looking for all things that are always true for parallelograms. Now, could you have a parallelogram that looks like this? Sure. Could you have congruent diagonals? Sure. Well, then you'd end up being a rectangle. But in this case, it's still a parallelogram because the diagonals still bisect each other. That's still parallel to this. This is still congruent to this. This is still congruent to that. This is still parallel. But if you add one extra characteristics like diagonals are congruent, which will also then force these angles to all be 90, well, then you end up getting things like a rectangle, which is a specific parallelogram. But in general, a general parallelogram has these characteristics, okay? One of the things that eventually we would look at is something like this. A nice little chart that says, here's all these characteristics, okay? A square has all of these. It is a parallelogram, and it's got all of these properties, extra properties. A rhombus has extra properties. A rectangle has extra properties. But just in general, if you just tell me you have a parallelogram, then we're looking at these properties. Two pair of parallel sides. Two pairs of opposite sides are congruent. Two pairs of opposite angles are congruent. I guess just opposite angles are congruent. Consecutive angles are supplements, and the diagonals bisect each other. And then we said there was one more way to prove a parallelogram other than these, is to show that one pair is both congruent and parallel. And that's another way to prove something. But these are really your properties of and the way to prove something is a parallelogram. And again, it could clearly be a higher level parallelogram and be a rectangle, and then boom, you got four angles that are all right angles and the diagonals are congruent. If you give me a little bit more and you say all four sides are now congruent, then the diagonals will actually be perpendicular and they'll bisect the angles and all sorts of stuff, and you end up being a square. Again, you can work your way down, but today we're really just looking at parallelograms, and most of today, other than me wanting you to kind of get introduced to this video, you're really just going to look at the area of parallelograms and do some problem solving. So today shouldn't be too long of an assignment. So you can go ahead and download the parallelogram area stuff, and you can kind of look through doing stuff like this. Thanks, guys.